Hello and welcome to my YouTube channel. Today's numerical class will give you a very specific concept. The concept regarding Gauss's law. I have taken two most important numericals from NCERT book and they are written here. 1.17 and 1.18. This is the question number from NCERT. It says 1.17 question says careful measurement of the electric field at the surface of a black box indicates that the net outward flux through the surface of the box is this one, 8.0 into 10 to the power cube Newton meter square per coulomb. It says that net charge inside the box is equal to what? If the net outward flux is equal to 0, then could you conclude about the charge inside the box is 0? First of all, I think we should write here that what are given. Given that the surface of the box is, this is the amount of outward flux, that is phi is equal to 8.0 into 10 to the power cube. The value of phi is given, Newton meter square per coulomb. We have to find net charge inside the box. We know by the formula that phi is equal to 1 upon epsilon times charge enclosed by the Gaussian surface. This implies Q is equal to epsilon naught times phi. We have to find Q. The first question says net charge inside the box. Let that is Q. We have to find it. That means Q is equal to epsilon naught. The value of epsilon naught is given 8.8 in 10 to the power minus 12. And we have to find that value of phi which is given, that is 8 into 10 to the power cube. After calculation, that is 8.8 into 8 into 10 minus 12 and minus 12 plus 3. It gives you 8.8 into 8 into 10 minus 9. This coulomb. After calculation, we can find its value will be 0.07 microcoulomb. This will be the answer. If you calculate, you will get this answer. This is the value of Q. The first question. The first answer you have obtained. Now second, it says that if the net outward flux is 0, then could you conclude about the charge inside the box is 0? The net flux outward, the net flux is 0, that doesn't mean that charge inside is not available. The charge could be equal and opposite sign. Two equal and opposite charges might be there inside, so that the net charge equal to 0. So you cannot say that there could not be any charge. There could be charge. However, there is an flux that is equal to 0. That means the answer will be no. If the answer will be, if the net outward flux is equal to 0, it means that there might be charge, but they will be equal and opposite. Okay. Now come to the second question, 1.18. A point charge of 10 microcoulomb at a distance 5 centimeter directly above the center of a square of side 10 centimeter, as shown of a square of side 10 centimeter. Okay, as shown means the diagram is already shown here, and that is, as you can write here, you can make a diagram here like a square surface is here, and just here is the charge. This is the square surface just I am making here. It is given portion, and above this above the center here it says that a point charge of 10 microcoulomb means Q is equal to, given that Q is equal to 10 microcoulomb at a distance 5 centimeter directly above the 5 centimeter directly from here, 5 centimeter means the distance 5 centimeter, that means at the center, as shown of a square 10 centimeter side is equal to 10 centimeter. So find phi through the square. Phi is equal to what? We can, for the sake of convenience, we can construct a cube. We can construct a cube, then so that making another surfaces that would be the virtual surfaces, and a cubical hypothetical surface that is the Gaussian surface, means cubical shape that is of according to the Gauss's hypothesis, Gauss's surface we can make here. So according to Gauss's law, we can say that if we make a cube, Gaussian cube, then the total flux phi will be equal to 1 upon epsilon times q, total flux. And this total flux, the q is given here, that is q is equal to epsilon naught into phi, that is q is given here. We have to find phi. That means you can write here the value of q, that is 10 microcoulomb, means 10 to the power minus 6 coulomb by epsilon naught. We can put the value of epsilon naught, that is 10 into 10 to the power minus 6, 8.8 into 10 to the power minus 12. And we want here, this is the total flux through the cubical surface. There are 6 surfaces. Okay, if we consider a cube, then this below surface, top surface, this surface, right, left, right, 4, and that, and here. That means 6 surfaces are there in cube. So 1/6 of this total flux will pass through this square. That means the required value of phi will be 1/6 of the total flux. Required flux is 1/6 of the total required flux, that is equal to 1/6 of the total flux, because the square surface is one of the surface of the cubical structure. That is 1/6 of total phi. Total phi means 10 into 10 minus 6, that is 8.8 into 10 to the power minus 12. After calculation, we can get the value of this whole numerical values, this whole steps. It will have, after calculation, it will give a value 1.88 into 10 to the power 5 Newton meter square per coulomb. This is the flux, amount of flux that will pass through this square surface. So I think you have got the concept. If you feel any problem regarding concept, please call me on my phone that is given in description. Okay, and now again I am appealing you, requesting you, please like and subscribe so that you could get the upcoming videos. I am laboring hard for your study. There is no harm if you like and subscribe, because it will be very, very beneficial for you. Okay, thank you.